Friday, January 20th. Okay, so we left off yesterday. We were talking about 45, 90 triangles and 30, that's so weird, 30, 60, 90 triangles. Okay? All right, so these are the side ratios of a 45, 45, 90 triangle. These are the side ratios of a 30, 60, 90 triangle. Okay, in radians, we're going to talk about these triangles in radians now. A 45, 45, 90 triangle is the same as a pi over 4, pi over 4, pi over 2 triangle. And a 30, 60, 90 triangle in radians, I'll put in the side ratios. Okay, a 30, 60, 90 triangle is the same as a pi over 6, pi over 3, pi over 2 triangle. Okay. All right, so this is all you need, okay? Write these down, draw these on your notes, okay? That's the trig Bible. That and the unit circle. That and the unit circle are so important, okay? Yeah, it's like the Old Testament. Unit circle is like the New Testament. All right? And then the law of cosines is like the book of Revelation or something. All right, so sine of pi over 3. What's the sine of pi over 3 then? See here?
Inside of that, it's pi.
Sorry, root 3. Wait, which one?
Yeah, the pi's inside.
Yeah, so this angle right here is a pi over 6 angle.
Pi over 6.
Yeah, sorry, it's really small. There's no way you can see it. Up here, the top corner is pi over 3, and then the right angle is pi over 2. So get those written down. Okay, let me point the camera at them. All right, pause the video right here. Draw these.
You're recording?
Yeah, I'm recording. Got my YouTube channel. Got 18 subscribers.
You know what?
Trying to get more than this board.
What is she? She has a lot, right? She has like 100. Hey, Jade. All right, so get those triangles written down. So what's the sine of pi over 3? Okay, so what's the side length that's across from pi over 3?
Square root of 3.
Yeah, so this is opposite side over the hypotenuse. Okay, SOHCAHTOA. So the opposite side is root 3. What's the hypotenuse length? Okay, are they really that bad? I'm sorry. Yeah. We might have. Do we get it written down? Do you guys want me to? Do you guys need me to redraw them, or? Okay, if we got them written down.
What's the one on the bottom, like the
Yeah. So
30, 60, 90?
what's the one on the bottom? Which one? This one?
Oh,
All of it? Yeah. Sorry. I'm just gonna open up a blank note. Okay. So in radians, oh gosh. It's going to be pi over 6, pi over 3, pi over 2, 1, root 3, 2. Okay? That's the pi over 6, and that's a horrible right triangle. I'm so sorry. Gosh dang it. I hate drawing. I can never teach geometry. All right, and then the pi over 4, pi over 2. Oh my gosh. All right. Okay, so get those. Those are the radian versions. And then for degrees, I'll just write the degrees down on the same triangles. This is going to be 30 degrees, 60 degrees, 90 degrees, 90 degrees, 45 degrees. Sorry about that. Let's get those written down real quick. Get those drawn up. Let me know when I'm good to go back to the notes. The notes? No, but I can post them if you want. Yeah. Just doesn't feel like drawing. Something wrong with that. All right, these are so important. I drew these all the time in college, all the time. Okay, so, okay, we need a little time. We good? Okay, no one's writing. Okay, I'm going to go back to the notes. You need me to just keep them up? All right, so sine of pi over 3. Okay, so look at your triangles. Okay, here's your, all right. Sine is what? It's opposite over adjacent, so the length of the side opposite the angle over the length of the hypotenuse of the whole triangle. Side opposite is root 3. Hypotenuse is 2, so it's root 3 over 2.
Wait, how do you know which triangle?
To use, which one to use? I'm using the triangle that has pi over 3 in it as one of the angles. So, yeah.
Oh, so that's just like the angle, so then you do the opposite.
Yeah, so the opposite side is root 3 and the hypotenuse is root 2. SOHCAHTOA, SOHCAHTOA. 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 Okay.
Wait, for the 90, then do you like, you just choose which one you do?
For like the sine or cosine of a 90-degree angle, we'll get to that. We're not going to get to that yet. That's a really good question. It's interesting. Okay, secant of pi over 4. What should we find first? We should first find the cosine of pi over 4. Okay? What's cosine again? Adjacent over hypotenuse. Okay. So what's the length of the side adjacent to pi over 4?
Wait,
1.
I have a question. How do you know which one it is? Because there's 2 pi over 4s?
It doesn't matter. It doesn't matter. Yeah. It doesn't matter. Yeah.
Oh,
So you
it's
could use
the
this
other
pi over
one's
4.
1.
Yeah. It's the same lengths. Sorry, I'm so. I gotta get new markers, guys. That's on me. Okay. And then the hypotenuse has length what in that triangle? Root 2. Yep. What did we say secant was? Is what?
Reciprocal.
Yeah, so we just flip cosine around. So it's going to be root 2 over 1 or just root 2. All right. All right, what about C? So I go to the pi over 6, the pi over 6, pi over 3, pi over 2 triangle. I go to that pi over 6 angle. What's tangent? Opposite over adjacent. So the opposite side, the side opposite pi over 6 is 1. Okay, so it's going to be 1 over, what's the adjacent side? Root 3, okay? Let's rationalize that denominator, okay? What do I do for that? Yeah, root 3 over root 3. Okay, so there's my tangent of pi over 6. Okay. How do I find the cosine of pi over 3? What's that going to be? Anyone know? Ka. Cosine is ka. So adjacent over hypotenuse. Yeah, no, you're good. So it's going to be 1 over 2. Okay. It's adjacent over hypotenuse. So this side adjacent to my pi over 3 angle is 1. The hypotenuse is 2. So it's going to be 1 over 2. Okay. Let's get that written down. Are we good? Okay. Next part, evaluate through calculator. Get your calculators out, please. I'll get Terry out. For those of you who are new, my calculator's name is Terry. Okay, Jack French came up with it. Why did he come up with it?
Why Terry?
I don't know. He just like said it under his breath. I had them on the first day of school write down like what they think I should name it. He didn't even write that down. He just like under his breath said Terry.
No, it was like.
He was like, Terry. And I was like, that's the perfect name. So Terry, we'll get Terry out. All right.
Oh yeah, it's like.
All right. So that first one, that first angle is secant of 10 degrees. What should I find first? Yeah, so I'm going to find cosine because that's the one I flip over to get secant. Okay. All right, so let's go. We're going to learn how to switch between modes. So let's make sure we're on degree mode at first, okay? So to switch to degree mode, I hit the mode button right here. Okay. You see, scroll down to that line that says radian degree. Okay. Hover over degree and hit enter. Make sure the degree option is highlighted. Hit graph, go back. Oh, dang it, now it's graphing an equation. Dang it. Okay. Graph, clear, okay. So I'm going to do cosine of 10 degrees, okay? I do that by hitting the cosine button, and then I put a 10 in, and I hit enter, okay? That's going to give me the right answer as long as I'm on degree mode, okay? How do I go from that to secant? Flip it. What button flips it on my calculator? X to the -1 button is going to flip it, okay? So 1.015.
What was that last part? X. What did you do that last part?
I need to flip. I need to do the reciprocal of cosine 10.
Wait, what?
So I hit the X to the -1 button.
Oh.
Needs to be in degree mode?
Needs to be in degree mode, yeah.
Could you also just plug it in as, never mind.
Okay. So 1.0154. I need to the 10,000th. So I want those first 4 decimal points. 1.0154.
How do we know when to like switch our calculators?
You'll get, so if you notice, there's a degree symbol. If there's explicitly a degree symbol, you want your calculator in degree mode. If there's no degree symbol, that means it's in radians. That's a really good question. So the angles that don't have degree symbols on them, those are radians. You need to make sure your calculator's in radian mode to do that.
So we have to flip it.
Yeah. So let's do all the degree ones first, so we can just switch once. Yeah, what's that number? What's that? Yeah. Yeah. Okay. All right. Tan 28 degrees and 11 minutes. First thing we got to do is what? You can't put minutes in your calculator, so we have to switch that angle to what? So what's that? Yeah, you have to switch it to decimal degrees. Sorry, yeah. So that's going to be what? 28 degrees. It's going to be tan of 28 point what? Point something degrees. 11 over 60. 0.183. So 28.183 repeating degrees. Okay. So I'm going to go on my calculator. Thank you. Oh, my apologies. Okay. Tangent. All right, I'm on degree mode still. Okay. 28.18 and then a bunch of 3s. Okay. I just did 7. Doesn't really matter. Okay. Enter. Okay. We want those first 4 decimal places. 0.5358. All right, so we're doing all the degrees first.
Wait, do you not flip it?
You flip it for a secant, a cosecant, or a cotangent. Yep, that's a really good question. All right, and then for E, I need to change that, right? I don't have minutes or degrees in my calculator, so I need to change it to decimal degrees. So it's going to be the sine of 129 points, and then I'll do 18 over 60 plus 13 over 3600. So 129.3036111111. Okay, just a bunch of ones. Okay. So that's the angle whose sine I want in degrees. Let's go back in here to my calculator. I'm going to hit the sine button. The sin button. 129.303611111111. I'm going to hit enter. All right, I want those first 4 decimal points. I'm rounding to the nearest 10,000, so that's 4 decimal places. So 0.7738. Oh, come on. All right. Okay, so are we doing okay with that? The sin button, the tan button, the cos button. All right. I was so happy when I finally figured out what those mean. I'd always wondered since I was a kid. All right. Then how do I switch back to radian mode real quick? Mode and highlight the radian. There you go. Let's stop there, I guess. What's that?
No, I just didn't have
Yeah, so that's different. That's inverse cosine. We'll talk about that later. What I want you to do is you would do TSC. You do the sine of that angle, and then you do the reciprocal, so 1 over that. Or you can just hit a little shortcut is the essence of 1. Inverse cosine is an entirely different one.
Wait, so did we get homework?
No, no homework. We haven't got through 4.2 yet. Let me check with this light, make sure I'm far enough.
Where you guys have to go?
I mean, we can. Are you older siblings?
What?
Kaplan sounds familiar. No, Kaplan, that does sound familiar. What year is he? Yes, yes. Okay. Yeah, you too.
I would like her if you were wondering.
Is that Baltimore? Is that you?
What was your name?
Lauren?
Lauren Cap. I definitely heard that. I knew it was familiar.
Yeah.
Okay. Cool.
Most people don't know most of us. A breath of fresh air.
Yeah, I remember names really well. So. Names sound familiar. I got B period coming up. Thank you. Dang. Oh, I should probably turn this off.